Voyager 1 is not dying in a blaze of fire. There is no explosion, no collision, no dramatic end. It is dying the way a candle dies, slowly, quietly, one flame at a time. Right now, at this very moment, a spacecraft the size of a small car is hurtling through absolute darkness at 61,000 kilometers per hour. There is no sun nearby. There is no planet in any direction. The nearest star lies trillions of kilometers away. Voyager 1 has been flying for almost 50 years, and it is currently the farthest human-made object in existence, over 25 billion kilometers from Earth. A radio signal traveling at the speed of light takes more than 23 hours just to reach it. What is keeping it alive is not solar panels. At that distance from the sun, solar energy is essentially zero. Instead, Voyager carries 3 radioisotope thermoelectric generators, RTGs, small nuclear devices that convert the heat from decaying plutonium-238 into electricity. When Voyager launched in 1977, those generators produced about 470 watts, enough to power a handful of household light bulbs. That modest supply of electricity was all Voyager ever had to run its computers, its heaters, its communication system, and its scientific instruments. The catch is physics. Plutonium-238 has a half-life of 87.7 years, meaning the fuel decays and the power output falls continuously. Every year, Voyager loses roughly 4 watts. Over nearly 5 decades, that loss becomes devastating. Engineers have been forced into agonizing decisions about what to keep running and what to shut down permanently. It is like a house where the power grid is slowly failing. First, you turn off the rooms you no longer use, then the heating, then the kitchen. Eventually, you are sitting in a single room with a single lamp, knowing that even that will go dark before long. Instruments falling silent one by one. When Voyager launched, it carried 11 scientific instruments: cameras, spectrometers, particle detectors, magnetometers. One by one, over the decades, they have been switched off. The cameras were shut down in 1990 after Voyager captured its most famous image, the pale blue dot, a haunting photograph of Earth as a tiny, pale speck suspended in a sunbeam, photographed from a distance of roughly 6 billion kilometers. The software controlling those cameras was deleted from the onboard computers. The ground equipment capable of interpreting the images no longer exists. Even if someone wanted to turn the cameras back on, they could not. By 2025, NASA engineers had shut down the cosmic ray subsystem, one of the instruments that had helped confirm Voyager crossed into interstellar space. The low-energy charged particle instrument is scheduled to follow. That leaves just 2 functioning science instruments, the MAG magnetometer and the plasma wave subsystem. 2 instruments on a spacecraft 25 billion kilometers away. That is all that remains. And it is not merely the instruments. The heaters keeping Voyager's fuel lines from freezing are also being turned off. If the hydrazine propellant in Voyager's thrusters freezes, the spacecraft can no longer orient its antenna toward Earth. If the antenna drifts off target, the signal is lost. Not temporarily, but permanently. There is no rescue mission. There is no reboot. You either maintain that razor-thin radio link or you lose the spacecraft forever. NASA engineers believe they can keep at least 1 science instrument running into the 2030s. The RTGs may provide enough power to transmit basic engineering data until approximately 2036, though these are optimistic estimates. After nearly 50 years in the most hostile environment imaginable, every day is borrowed time. A single unexpected failure, a frozen thruster line, a glitched computer, a degraded component could end the mission overnight. What 50 years achieved? What Voyager 1 accomplished in those 50 years is staggering. It flew past Jupiter in 1979, discovering active volcanoes on the moon Io, something no one had predicted. It reached Saturn in 1980, revealing intricate ring structures and giving us our first detailed look at Titan's thick, hazy atmosphere. After Saturn, Voyager's trajectory flung it upward out of the plane of the solar system on a one-way path toward the stars. For the next 3 decades, it kept going, past the orbits of Uranus, Neptune, Pluto, and beyond the Kuiper Belt, into regions where no instrument had ever measured anything. Then, in August 2012, something extraordinary happened. Voyager 1 crossed the heliopause, the boundary where the sun's influence ends and true interstellar space begins. This crossing was not a single clean leap. First, it passed through the termination shock, where the solar wind abruptly slowed. Then came the heliosheath, a turbulent region where solar particles mixed with interstellar matter. Finally, the heliopause itself, the edge of the solar bubble. Voyager was the first human-made object to leave it entirely. Its twin, Voyager 2, would later cross the heliopause in 2018, confirming what the first had found.
For the first time in history, humanity had sensors operating in the space between the stars. The data Voyager returned was not simply confirmatory. The interstellar medium turned out to be different from what many models had predicted. Magnetic field strengths were stronger in certain ways. Plasma density defied expectations. Voyager did not merely verify existing theories, it challenged them. That is why every remaining watt of power matters. Every day those instruments stay on, they collect data from a place no other spacecraft has ever been or will be for decades to come.
The scale that cannot be grasped. Voyager 1 is currently about 165 times farther from the Sun than Earth is. In late 2026, it will reach a milestone that sounds almost poetic. It will be 1 light day from Earth. A command sent from NASA's Deep Space Network will take a full 24 hours to arrive, and another 24 hours for Voyager's reply to return. A simple exchange, a greeting and a response, takes 2 days at the speed of light. And yet, despite all that distance, Voyager has barely scratched the surface of what lies ahead. The Oort cloud, the vast spherical shell of icy objects marking the gravitational edge of our solar system, is estimated to begin somewhere around 1,000 to 2,000 astronomical units from the Sun. Voyager is currently at about 165 astronomical units. At its current speed, it will not reach the inner boundary of the Oort cloud for several more centuries. The outer edge lies roughly 100,000 astronomical units away. Voyager will not clear the Oort cloud for approximately 30,000 years. 30,000 years just to leave our solar system's gravitational neighborhood. For context, 30,000 years ago, humans were painting on cave walls. Agriculture had not yet been invented. Not a single city had been built. That is the timescale we are talking about, and Voyager will still be nowhere near another star. It will get there eventually. In about 40,000 years, Voyager 1 will make its closest approach to a star called Gliese 445, a small red dwarf currently about 17 light-years from Earth. Because stars are in constant motion, it will be much closer by them, roughly 3.5 light-years away, and Voyager will pass within about 1.7 light-years of it. That is still over 16 trillion kilometers. Voyager will not enter any solar system, it will not orbit anything. A silent, cold piece of metal will drift past a distant star, and then it will keep going. The long silence. Sometime in the 2030s, by cosmic standards almost immediately, Voyager's power will drop below the threshold needed to operate anything. The transmitter will fall silent, the computers will shut down, the heaters will stop, the internal temperature will plunge toward the background temperature of interstellar space, just a few degrees above absolute zero. And then Voyager will enter a new phase of its existence, one that will last incomprehensibly longer than everything that came before. Without power, without communication, without any functioning system, Voyager 1 will continue moving at 61,000 kilometers per hour. Nothing will slow it down. In the vacuum of interstellar space, there is no friction, no drag, nothing to oppose its motion. It will drift through the galaxy for millions of years, then hundreds of millions, then billions. Researchers have calculated that it could take on the order of 10 to the power of 20 years, that is 100 million trillion years, before Voyager would statistically collide with a star. A timescale so vast that the stars themselves will have burned out long before it is reached. Voyager will outlast the Sun. It will outlast every star currently shining in the Milky Way. It will outlast the Milky Way itself. Long after our galaxy merges with Andromeda, long after the last red dwarfs flicker and die, Voyager 1 will still be out there, drifting, silent, cold, carrying on its side a golden record. The message we sent. That golden record contains 115 images, greetings in 55 languages, 90 minutes of music from around the world, and the sounds of Earth, wind, rain, birdsong, a mother's first heartbeat. It was designed by a team led by Carl Sagan, assembled in the hope that someday, somewhere, something might find it. The odds are vanishingly small. Interstellar space is so incomprehensibly empty that Voyager could travel for longer than the current age of the universe without encountering anything at all. The golden record will almost certainly never be played by alien hands. But that was never really the point. The point was that we made it. That a species confined to one small planet, still learning to walk upright in the cosmic sense, looked up at the stars and decided to send a message. Not a weapon, not a warning, a greeting. Music and mathematics and images of who we are, attached to a spacecraft that was only supposed to last 4 years, and instead lasted 50. Voyager 1 cannot go on forever. Its instruments are fading, its power is draining. Sometime soon, by any scale that matters, it will go quiet. But it will never stop moving.
It will carry our voice into the galaxy long after there is no one left to speak. And perhaps that is the most extraordinary thing about Voyager 1, not how far it has gone, but that it will keep going long after we are the ones who are gone.